In this video, I'm going to focus on the next problem right here because I think it's going to take the full 8 minutes or 10 minutes that I like to keep these at. It's deceivingly simple. I've written it down, but I want to remind you that theta is in this function a number of times. Don't be fooled. This isn't a number. This is a theta. It's an input to the function. It changes based on what you decide to set it at to see what you're looking at. And that means when we take a derivative, it counts as a function, just like e to the theta tan theta. So the first thing I want to do to find the derivative of this is distribute, and I'm going to write like this: d theta of e to the theta tan theta. Sorry, I'm leaving some parentheses out because it's not very necessary right now. Minus d theta of e to the theta, I'm going to write it in this order, times theta. Because I want to point out that this is two separate product rules separated by simple addition. Okay? And if it's separated by simple addition, meaning a plus or a minus, then that means we can approach these separately. And I want to do this guy first, and then we'll do this guy second. And then the first one is a product rule, and it's not going to be that bad on one side because we have u equals e to the theta, and u prime, the exponential rule, says it's the same. That's awesome. And our v for this one is tangent theta, which is, of course, sine theta over cosine theta. That's what tangent is. So v prime is going to be the derivative of this. And what's the derivative of this? We're going to need a different color to operate with because we have a u and a v for a quotient rule. We have to take the quotient rule to find v prime here. So that's u prime v minus v prime u over v squared for this function. Okay, so what is that? Well, we know that u for this is sine theta. U prime, what's the derivative of sine? It's cosine theta. V is cosine theta. And v prime is negative sine theta. So to find v prime, we'll do u prime v, which is cosine cosine. So that's cosine. Uh-oh, I think my computer's getting a little hot. 1 second. Trying to record for y'all. It's going to melt my machine. Cosine squared, and then minus v prime, so it's going to be plus sine u, so it'd be sine theta squared, and that whole thing is going to be divided by cosine squared, v squared. Just heard my dog take a big fart. Okay, cosine squared plus sine theta squared is, of course, 1. So we're just going to put 1 here. And now we can include that in our actual product rule here. Okay, so I'm going to keep it on the left side because I want to do the other part too, you know? So let's do, what's the product rule for this? U prime v plus v prime u. That's not a very good u, is it? And what is here's our values here. So we know what u prime is. That's e to the theta times v, which is tangent theta. I'm hoping we're done with this so I don't have to leave it as sine and cosine at this point, but who knows? Plus v prime, which is 1 over cosine. You know what? Let's write it as what it is, which is secant theta. Oh my gosh, it's not wanting to. Squared times what? E to the theta. That's what u is. Okay, so that's what we have there. Let's look at the second side of this here, over here. d theta. This is another product rule, isn't it? So let's get our original ink color back out. Our u value is e to the theta. U prime is e to the theta. V is theta. What's v prime? 1. Right? I think it's 1. So what's u prime v? That's theta e to the theta plus v prime u, which is 1 e to the theta, like this. So let's bring that down. Notice this was a minus in between here, right? So we want to put that in the whole quantity. And we'll do minus theta e to the theta plus e to the theta. I should have written this in our darker color to stay away from the confusion, but I guess I got ahead of myself here. So what can we factor out? Well, some of this is obvious, right? We can definitely take the e to the theta out. And then we have tangent theta plus, your teacher may write it as secant squared theta, but you know me, and I hate that. Because why? Why would we put the exponent in the middle of your function notation? It makes no sense. I put it out here. Tell your teacher to call me if they have a problem with it. And this would be a minus theta minus 1. That is probably the most condensed version of the answer you can get for the derivative here. And this is kind of a mind bender, so let's just call it there on this video and do the other two in the next one.